Question number 14. A clock is regulated by seconds pendulum, keeps correct time. During summer, the length of the pendulum increases to 1.02 meters. How much will the clock gain or loss in one day? Okay. So here there is a one clock and it is regulated as seconds pendulum. Okay, so we all know that seconds pendulum time period t is equal to 2 seconds and length L is equal to, so actually it is equal to 1 meter or 100 centimeters, but this is not accurately. So that accurately, if you are getting for that length, so we have a formula, that is what t is equal to 2 pi under the root of L by G. So for this we are squaring on both sides, and that is t square is equal to 4 pi square, and this is L by G after squaring on both sides. Then t is equal to, already we know that this is t square means it is 4, and this is 4 pi square L by G. Okay, from that 1 4 cancel, then L is equal to that is G by pi square. So this is actually method. So here G is equal to 9.8 and pi is equal to 3.14 whole square. So if we are doing that calculation, so we got it. We got that value is 0. This is 0.9927. This is the actual length of the seconds pendulum, but we are taking it is as almost equal to 1 meter. So in this problem we are taking this accurate length of the seconds pendulum. Okay, so here in this question what they are said, that is equal to, so it is the seconds pendulum, the clock is regulated by the seconds pendulum. Okay, so this is our clock and it is regulated by seconds pendulum. Then so in summer length of the pendulum increases. Okay, so this length is 0.9927 and it is increases. Okay, that is I am taking here L2, and that L2 is equal to 1.02 meters. Okay, the length is increases from 0.9927 meters to 1.02 meters. Then what is the change in the time? Okay, how much will the clock gain or loss? What is the gain or loss here? For suppose we have a this is the 1 minutes and seconds and like that we have a in wall clock. So when length of the hand is increases, its speed is changing, means velocity v is equal to distance by and time. Okay, so when time is increases, speed is decreasing. Okay, our distance means here what? Length. When length is changing, its velocity is also changing. Okay, here it takes the it is when length is increasing, okay, its velocity is also increasing. Okay, then length is decreases, then velocity is also decreasing. If velocity is decreasing, it takes more time to complete 1 second, 1 second or 1 minute. For suppose for 1 minute it is equal to 60 seconds, but when length is increases, length is decreasing, so its speed is also decreasing. When speed is decreasing, it is taking the more time, that is for suppose it is equal to 61 seconds. Okay, for 1 minute it is taking 61 seconds. Because of the when length is increases, velocity is also increasing. Okay, so and when length is decreases, velocity decreasing. Okay, so when velocity decreases, to complete one rotation, it is taking more time. Okay, then when length is increasing, then velocity is also increasing, and it is completing within the 59 seconds only. It is an example. So how uh, time is changes when length of the hand in clock is changing. Okay, so here is also there is a one clock. It is regulated by the seconds pendulum. So the seconds pendulum means 2 seconds, its time period. So for one complete oscillation, and here length of the pendulum is 0.9927 meters. Like that here, when this length is increases to this L2, that is 1.02 meters from 0.9927 meters, then what is the change we will observe in the seconds pendulum? How much time error in the time? Okay, how much error in the time that wall clock is showing? Okay, so for that, here I am taking that is capital T. This is time period, and it is directly proportional to root L. From the equation, T is equal to 2 pi under the root of L by G. Okay, so when length is increases or decreases, its time is changing, so that is equal to here. So that's why these two are proportional. Length increases, time is also increasing. If length is decreases, time is decreases. Okay, so then from this equation, now we have to find out the how much error that wall clock is showing, or that seconds pendulum is showing. So error means sometimes when length is increases, when length is increases, uh, velocity is also increasing, means it takes very small time, that is 59 seconds. In 59 seconds, it is reaching the, that is 1 minute, means where we lost 1 second because of the length increases. Okay, so like that there is some error in the time. So that's why here also we have to find out the how much error in that uh, seconds pendulum clock while increasing the length. So we are following the error method. So that's why here we are taking the um, relative error in time and also relative error in length. So relative error means the error in time by original value, that is equal to t, and which is equal to here, this is error in length by original length, that is L. And in errors, if there is any powers while taking the relative errors, that powers are comes here like this. Okay, so I think you have an idea, that is x is equal to a to the power of n, means this is we are writing like this: delta x by x, relative error in x, is equal to n into delta a by a. If anybody not remember this, once go to the chapter 2, there we have this relative error relation. Okay, so this is the relative error. Now from this we can find out the how much error in the time. The delta t is showing the error in the time, and this is the initial time, and this is change in length of the pendulum, and this is initial length. So then from that we can write here, this is equal to dt by t. T is the seconds pendulum time, that is equal to how much? 2 seconds. Time period of the seconds pendulum, it is equal to 2, and this is equal to 1 by 2, and this is delta L. Delta L is equal to nothing but here, this is L2 minus L1. Okay, so that is L2 minus L1 by this is L1. Okay, so from this 1 to 1 to both are cancelled. Okay, so that is dt is equal to this is how much? L2 minus L1. Sorry. L2 is equal to how much? L2 is equal to 1.02 minus L1 is equal to, this is 0.9927 by L1. L1 is equal to 0.9927. Okay, so from this delta T is equal to, after subtracting this in the numerator, we got it 0.0273. This is 0.0273 by, this is 0.9927. This is the error in the time while increasing or decreasing the length. Means sometimes it is lost sometime and sometimes it is gaining. Okay, here when it is 61 takes the time 61 seconds for the 1 minute, then here 1 second is gained, and when it is 59 seconds it is lost 1 second. So like that there is a time gaining and time lost by increasing the or decreasing the length while changing the length of the uh, pendulum. Okay, so then how many seconds per day? Here we have to find out that what are the change. Okay, so 1 minute please. So here in this question they asked that how much will the clock gain or last lose in 1 day. For 1 day how many seconds are there? Okay, so 1 day means 1 day is equal to 24 hours, and that is equal to 24 into 60 minutes and 60 seconds, and which is equal to 86,400 seconds. This is for 1 day. Okay, so for 1 day these are the seconds, 86,400 seconds. Then how many oscillations are possible? Okay, so that is uh, 86,400 seconds for 1 day, but it is a seconds pendulum. So seconds pendulum is taking the time to complete one oscillation, that is equal to how much? 2 seconds. So that's why the number of oscillations by seconds pendulum in 1 day, and that is number of oscillations is equal to, that is total seconds is how much? 86,400 seconds by 2. Okay, so because for every 2 seconds it is completing one oscillation. Okay, so there are how many seconds are there? It is 86,400 seconds for 1 day. So then if you are divided that 86,400 seconds by 2, then we are getting the number of oscillations in a day. So that is equal to, it is 43,200 oscillations. Okay, so that wall clock or that clock is uh, performing the 43,200 oscillations in 1 day. Okay, so then in every oscillation how much we lost the time, that is equal to delta t. Okay, so this delta t is what? Error in the time. Okay, error means, delta t means time is here nothing but it is time taken for one oscillation. So how many oscillations are completed in 1 day? That is 43,200 oscillations. Okay, in every oscillations this much of the error. So then now multiply here, then we got the how much loss, sorry, the time lost time lost or gain by the clock. Okay, so maybe it is lost or lose, or maybe gain, that is equal to how much? 43,200. Okay, these are the oscillations in one day. For one day, this much of oscillations are there, and every oscillation, how much time we lost? This is the number, that is equal to 0.0273 by 0.9927. Okay, so then after multiplying, after solving this, we got it, that is equal to 1180 seconds. Okay, this is our problem. Okay, so maybe you can understand it. So this is the time period for seconds pendulum, 2 seconds, and length of the pendulum is length of the seconds pendulum is accurate length 0.9927 meters, but this length is increased to L2, that is equal to how much? 1.02 meters. In that case, it is showing some error in the time. That error we have to find out. So for that we are taking this one. Okay, error method. So T is directly proportional to root L, because time period is depending on L. So here length is increased, so the time may be changing. Okay, so that the change in time is nothing but here error in the time delta T by T is equal to a root means here 1 by 2, L power 1 by 2. If any power is there, that is we are taken like this in our errors chapter. Already we have an idea. Then from that we are following this, that is dt by t. T is the time period, that is equal to 2 seconds, and 1 by 2. Delta L is nothing but final length, that is 1.02 meters, L2 minus L1, and we are doing that. So this is the dt is equal to 0.0273 by 0.9927. This is the error in every oscillation. Okay, every oscillation means every cycle in a wall clock when it is completed 1 minute. In that 1 minute, how much error is there? 0.0273 by 0.9927. Then here we have to calculate the how much error in the 1 day. 1 day means that is equal to how much? 24 hours, and it is equal to 86,400 seconds. Okay, for 1 day that clock is taking the time, that is equal to 86,400 seconds. But how many oscillations it is completed? It is a seconds pendulum. Okay, so it is seconds pendulum means uh, it takes the 2 seconds for one oscillation. So that's why the total seconds whatever there for 1 day, and these are divided by 2 seconds, then we got the number of oscillations by seconds pendulum in 1 day. So our seconds pendulum is performing 43,200 oscillations. Oscillations means here, for suppose in general it is 43,200 cycles by the seconds and or minutes and or hour and. Okay, in every oscillation, okay, how much time it error is there in every oscillation. Okay, in every oscillation, this is the error. So these are the number of oscillations in every oscillation, this is the error. Then we are multiplying in these two, then we got the total error, maybe that is lost or gain, that is equal to 1180 seconds.